which came back from your anticipating. Like, it all just has to keep coming back to those initial pieces. So every ring requires the rings inside it.
Okay, what do you think about that? So can you monitor effectively without having anticipated?
No.
Can you select without monitoring? It's absolutely impossible. You absolutely must be able to, you have to have monitoring in order to select. And then you have to, in order to sequence, yeah, you have to know what you selected to sequence. And of course, connecting then requires all of them. So, what do they mean by, they talked about authority versus accountability of the students. Remember that? What were they talking about with that, and what would be the problem with emphasizing one or the other?
They're both important. Authority is where, because you've monitored and you've selected and you sequenced correctly, the student has presented the idea as if it's their idea, and so they own it. They are authority on that idea. The accountability is that they have to connect their ideas with other people's ideas to find the connections. That's their connection. So both are very important.
What other aspect to accountability is there? So she said they're accountable to connect it with other students. Is there anything more to accountability?
You have to be like accountable to the subject of math. You don't want to let them just sit there and not understand all the concepts. You need to make sure that they don't just learn how to, they need to understand the background concepts and be accountable for everything, not just what they decided to learn about. You need to make sure they cover everything.
Yeah, and so that's part of the connecting phase, right? So you have a goal for the whole lesson of, what are the mathematical ideas that you want to get across? What conversation do you want to have? And so they may, think and work on their own. That's great, but they can come up with wrong thinking. They can have thinking that's in error and confusion. And so part of the connecting phase is you're helping them improve their way of thinking about it. Yeah.
So going back to the show and tell thing, that's one thing. The main thing show and tell doesn't have is it lacks the accountability.
That's right.
And then that, which is the base. That's building the whole base. Because then once they have a base of all the possibilities that they can build more, and it's a building. Accountability builds a base. Foundation.
Chris?
I was going to say also by doing that, if you make it so the students have to stay engaged the whole time, because otherwise, most of the time, if they're not presenting, they're not participating, they're not staying engaged to what's going on up front.
Mm-hmm. Yeah.
I think it ultimately, when you do the show and tell, it undermines their authority. They're looking to you for an answer as to whether or not they were right or wrong.
Okay. Jocelyn, were you done? Yeah.
I was going to say, along with that, like, an important part of authority is that, like, from what I understood, is that the student has a right to their understanding. Like, if they go up and they present something, even if they're wrong, they shouldn't feel ashamed.
It's good.
Like, they need to feel comfortable expressing their understanding and feel comfortable if it's wrong and adapting to a different understanding or furthering their understanding.
Yeah, so that is huge. Creating a comfortable environment, a safe math environment where you can express your ideas, and it's okay if you're wrong. That's the golden ticket, and that's a challenge. That's a challenge. So, as you were reading, did you think about yourself engaging in these practices? Can you imagine yourself using it? And so, what was that like? Somebody new. How about Matt?
It's one of those things that it can be kind of difficult to sort of really wrap our heads around, because a lot of, I know my own experience as a student of math hasn't really, but I haven't seen a whole lot of this. So actually seeing how it can apply not just to these like really specific lessons that we have seen here in college that are sort of tailored for it, but in an everyday sense, it's one of those things that I'd like to be able to tell myself, yes, I could totally see myself doing this, if hopefully not on all the hard to really tell myself that because as much as I want to, I don't have the experience for it.
Yeah.
So I think it'd have to be a work in progress.
Yeah. So what was the way that they said it could be a work in progress? Like in the end, it could be something that you develop. They made a suggestion about the way. Does anyone? And then Brianna, you'll be next after this question. Yeah. Brianna, this Brianna will go now, and then that Brianna will go with her original thought.
Well, they talked about how you could try like one step one day and the next step the next day and kind of like build on it to practice, not necessarily try all of it at once.
Yeah, so you would be doing all of it at once, but you're really working on one or two of the phases at any one given time. So it's like, okay, for this first week, I'm going to do it all, do my best, but I'm really going to work on anticipating. I want to work hard before the lessons to work the problem. There's the number one thing about anticipating. I'm going to do it myself and see how many ways I can come up with about in terms of thinking about it, and then really work hard at anticipating. And then maybe in a couple weeks, then you really think about monitoring. And so then they said over time, if you kind of rotate through them, then you start getting good at all of them, you can start implementing all of them at once. Now, let's go back to your original thought. You were...
I was just going to say I thought the articles were very interesting because it was eye-opening in the sense that when I've written lessons in the past or delivered lessons, like I've never gone that in-depth about everything or thought so critical about a lesson. And it's kind of almost like just with technology, how it changes over time, and teaching styles have been updated and they're constantly changing, and so I just think it's changing for the better. Just like with technology, it's something that teachers are going to have to kind of just evolve with it.
Okay.
Another thing that you showed us last class that was kind of, I would say, upsetting was the stats of how the teacher classroom viewed as medium and low instruction. And these articles are really optimistic in the sense that we're ready to kind of start challenging kids because math is not easy. Math does take a lot of hard work, and math can be applied to a lot of aspects of life. So I wrote in my response in these for both these that there's a very optimistic view saying I want to challenge my students because I know they can handle it. Because when students are being challenged, you're expecting a lot of them. They can say, well, this person thinks I can do it, then maybe I can. So that was kind of something I saw. It's kind of same thing involved in teaching. It's like we got to stop setting these low bars for each other. We got to kind of start raising the bar a little bit.
Okay, what about the other article? Excuse me. So how would you compare it? What would you say about the other article compared to this morning?
It's the same thing, but in 3 cute little steps.
Okay. You thought it was mostly the same. Jason?
Yeah, I mean, I thought it was mostly the same, but it was your first step. So, to try going about anticipating everything, I think that model is a lot less intimidating, especially for, first-coming teachers and everything like that. And so once you can kind of get that process down, then you can start kind of taking on the 5 in the first or the longer article. But like I said, in my opinion, they're pretty much the same. And one thing that they brought up in the second article was not having to do it all at once. Like they mentioned in this one as well. But I think one of the cool things they said was to don't worry about doing it all at once and kind of just go school year to school, year to year, and build up that repertoire for yourself. And so after a few years, you'll have, all the TTLP lesson plans that you can fall back on, and you'll have that big chunk, so you're not overwhelmed with trying to get them all at once. So that was nice. Like I said, it's just less intimidating than this one, especially for just going into teaching.
Okay.
I agree with him, and how, in this one I thought they mainly focused on how the teachers, would kind of feel about adapting to this new kind of lesson plan style, and they just stressed the importance of, what the goal of doing this new style was. It was just moving away from, the structural component to actually emphasizing, mathematical understanding, and how a teacher shouldn't worry about, only 50 minutes, and I have to do all of these things to comply with this. But it's just a work in progress about how much you can do.
Yeah, she's starting to hit on, there was a kind of a different emphasis on this article, and she's starting to hit on that. So what What did they emphasize or really attend to in this article in terms of what they encouraged? Chrissy?
I liked how they, with their, what was it called? The little example of how to go through it, how it actually gave you questions to ask yourself, gave you
Okay.
questions to ask the students to help them anticipate, because that would be my hardest part,
Okay.
would be get the actual questions. As in the other article didn't actually tell you questions to go through.
Yeah, so having good questions ahead of time, planned out, is crucial. Is there a hand in the back there? So how is this one different? Matt?
One thing I really felt, well, I don't know, I guess the biggest difference between them that I noticed when I was reading them is the Smith article I felt was more focused on like the theory of what's going on, why are we doing this, whereas this other, like the 5 practices, thank you, article I felt was a lot more focused on actually more rigorously how do you actually do this. I felt that the Smith article, it was more geared towards sort of teachers of sort of our own generation who are learning all these practices while we're going through our studies. Whereas the 5 practices, I thought it was geared more towards maybe even like a bit veteran teachers who've been in the field who need a way to sort of like, okay, how do I actually do this? Because I felt this 5 practices was a lot more detailed. It actually listed through just very in-depth, not necessarily as heavily as to why, like in the mathematical practices, that this is what we need to be doing, but how do you implement this?
Yeah, so definitely the Smith article, the shorter one, attended more to mathematics content. And this one could be applied to maybe science or really broader fields, whereas that Smith article is really about mathematical content. And it really, if you noticed, but they really emphasized attention to student thinking. Did you notice that that was their goal? It was about how the students are thinking about it, and listening to student thinking, and attending to what's going on with them. What are they? How are they processing this? Marty?
With the 5-step, I think it went over a little bit more about the sequencing and the manipulation of the student thinking. To be dealing with teenagers, to be a good influence, you have to know how to manipulate them, and not have them know that you're manipulating them, because then they stop. But there's ways of doing it, and you're a lot more successful if you know the practice of doing it. And that's the 5 steps cover that a little bit better, about manipulating the conversation and controlling it and moving it in a direction. That is more sequential on those steps.
Talking about the end, the connecting.
So the whole process.
The whole process.
Anticipating and manipulating.
Okay, any other comments? Yeah, so maybe the Stein article was a little bit more geared towards kind of like how you do it, different approaches, how you do it to get an answer, and then maybe students explaining their thinking. When the Smith article was really about the teacher, attending to what's going on with the students as they're thinking through it. Okay, so what I want to do in transition here. Oh, let me talk about feedback. So I've graded almost everything you've given me. There's one set of papers that I haven't graded, and of course the new ones. But everything else has been graded. So in terms of feedback, I want to encourage you to either email me or come visit me if you want to know why did I get a C- on this. Okay, so I really encourage you to do that. I'll take the time to do that. I kind of get the feeling sometimes I'll spend lots of time for 30 people writing out feedback, and I kind of get the feeling that it's not really read. So I want to encourage you to seek me out for that, okay? Because I want to put the time into organize good projects and good class sessions for you guys. And so I just leave it up to you to come find me for feedback if you're wondering why you got a certain grade on something. And I'm happy to take all the time that you need for me on that. Okay. So the next article you're going to read is it's written by Dr. Thompson, who's here on campus, and it's about what's called didactic objects. And so A didactic object is anything you use, anything you design and you use in your lesson to build a conversation to support the students getting the ideas that you want to get across. So and you'll read all about that. And so what I want to do is I want to kind of lead a lesson for you guys, and then you're going to read that article and hold up what I do, what I've presented to you in the lesson against that article. So you're looking for didactic objects, and how is it a didactic object, and how did I design it? Why do you think I designed it the way I did? What was my intention, etc. Another thing you can think about too is I'm going to ask lots of questions in this, but there's about 10 key questions that I've planned ahead of time. Okay, and so I want you to, you can go back and play the video, and I want you to kind of attend to her. And what were the questions that you really was thinking about ahead of time? Were the main questions. So the lesson that we're going to do is I did this last Friday with my Calc 1 class, and it's a lesson on linear function. Okay, so let's do it. So you are students, and I am your calculus teacher. Maybe. Okay, so if you have some, pretend if you have something to take notes on, you're going to have to write a little bit. So here's the scenario that we're going to look at here. It says two painters have started painting their respective houses. At a certain point, the first painter has already painted 100 square feet, and the second painter, P2, has already painted 400 square feet. So, Jorge, I'm showing you a green bar and a purple bar here. How might the green bar and the purple bar be representative of this scenario? So, what do you see? How might they represent?
How are they represented?
Yeah. How does the visual an illustration of the situation?
Well, we're given that we have painter 1 and painter 2, where painter 1 has already painted 100 square feet. Painter 2 has painted 400 square feet. So, based off those bars, we see that one is approximately 4 times more than the other.
Okay.
So we can, in this case, we can use the green bar to represent painter 2 and the other bar for painter 2.
So he wants the green bar to represent the area painted by P2, and the purple bar to represent the area painted by P1. You guys agree with that? Good. So let's define variables here. So let's call x. Let's call x. This is the area painted, and I want to be clear here. Try that again. Okay. We'll say x is the total area painted by P1. In, is it square feet? And y is the total area. Some days my writing is nice with this thing, and then there's these days. Okay, total area painted by P2 in square feet. So x is represented, just to review, x is represented how here in this diagram? So how is x represented? What about the purple? Let's be specific. What about the purple bar is x?
It's a unit.
What's that, Joel?
The length.
The length of it, right? So the length of it is the quantity x, and then the length of the green bar is quantity y. Okay, so what I'm going to do is I am going to, so painter 1 is going to paint 100 more square feet. How could I represent that? So Ashley, how could I represent painter 1 painting an additional 100 square feet?
Making the purple bar twice as long as it is now.
Ah, I had it. Okay, is that what you meant?
Yes.
Okay. And so, is the total amount painted by P2 proportional to the total amount painted by P1? How about Melissa? Is the total amount, so here what I showed is painter 1 painting 100 more square feet, and the corresponding additional amount that painter 2 painted when painter 1 painted 100 more square feet. So is the amount painted by P2 proportional to the total amount painted by P1? What's that?
No.
Why not, Melissa?
Because you're basically expanding the amount of the 100 square feet, like by twice a bit.
Okay.
So for the green line, or for painter 2, it was proportional, it would have been 800 square feet.
Okay, so if did you say this one doubled? Is that what you said?
Yeah.
So then you said that this one should have doubled as well. Okay. What do you think about her reasoning there? Agree with that? Jocelyn?
I agree with it under the assumption that the painter will keep a consistent painting speed. Like, maybe, I don't know, maybe like the second painter started off painting that much, but if he would slow down over time, then maybe it wouldn't be double, but...
Were you arguing for proportionality or against proportionality, Melissa? Against. Did you hear that she was arguing against proportionality?
And I agree with that it's
Okay.
not
Okay, so yeah, it sounded like maybe you were saying that she. Okay. Yeah. So are we in agreement that those are not proportional quantities? What might I be representing by a thinner bar here? Why might I have chosen a thinner bar for the additional amount painted? What might that represent? Michael, any idea?
Thinner bar, like height ones?
Yeah, so I started with these initial amounts, and then we added this additional amount of 100 square feet, and then this corresponding additional amount. So what quantity might I be representing by showing it as a thinner bar? Progress, okay. What quantity?
Progress made in square feet.
What's that?
Progress made.
In square feet. Anybody? What might I be showing?
Like delta x?
Whoa.
In quantities.
What's that?
You want like delta x, or are you talking strictly in quantities?
Is delta x a quantity?
Yeah.
Sounds like you're saying that those are exclusive.
Well, that's not delta x. Well, if we just tell what our original what we're working with and what our final output is after, if they were the same thickness, we would have known exactly.
Okay, so what's the final here? Okay, so what might I be representing with an additional amount of quantity x? Joel? Delta x. Okay, what's the new total amount of quantity y? 550. I'm going to make this darker. Can't see it. Is that better? Okay. So where might delta y be represented in this picture? Songling?
Between the 550 and 400.
Yeah, so the thin green bar would be like delta y. Okay? New question, are the changes the additional amount painted by P2 and is the additional amount painted by P2 proportional to the additional amount painted by P1? James, what do you think? Is the additional amount painted by P2 proportional to the additional amount painted by P1?
If you gave a second interval,
So he says not enough information. Anyone want a reason for yes or no? That the changes in the amount painted are proportional to one another, given the information that you have. Yeah, Eric?
It could be proportional to this one change, like you were saying, if we did the second one, we could see if it would still stay at the same rate. So it may be proportional to this specific change, but we don't know if it's proportional to the overall.
So you agree with James?
Yeah, it's proportional.
Okay. So I'm going to show you some more painting. Not that much. Trying. It's really sensitive. Trying to get it right there. So what I want you to do is, come on. Sorry. What I want you to do at your tables is, based on now, so now painter 1 has painted another 300 square feet, and here's the corresponding amount painted by painter 2. What I want you to do is make a tables of x and y values. So this is what's x and y represent? Total painted by P1 and total painted by P2. Whereas delta x and delta y represent additional amounts painted by painter 1 and additional amounts, corresponding additional amounts painted by painter 2. So I want you to come up with as many, actually, before that, I wanted you to come up with as many, I kind of jumped the gun there a little bit. In this scenario right here, come up with as many ordered pairs of either kind that you can, okay? So given all the information you have, how many ordered pairs of x and y can you come up with? How many ordered pairs of change in x to change in y can you come up with? So if you create your table, take about 2 minutes to do that, or a minute even. Go. So as many ordered pairs as you have information for.
Oh, I see another one.
Okay. Carolina, do you have a ordered pair of x and y that you can report? 200 and 550. Everyone agree with that? Okay. How about, let's see, Missy. Is there another x and y ordered pair that you have? 100 and 400? Okay, any other order pairs that we know? Jocelyn? 0, 0. Agree? We know that? 0 and 0?
I don't actually know that. Yeah, well, that's not labeled if it's on the same time or not.
Did they start at the same time?
They didn't tell us that.
So should I leave it or take it off?
Take it off.
Yeah, this is not, we're not sure about this, right? Okay, how about the change in x to the change in y? Frank?
100, 150.
And keep going. Christopher? Another change in x and change in y.
I was thinking
200 and 300. Where did you get, so where does that come from?
I was thinking about like what was going to happen next.
Okay.
If it stayed at a constant rate,
Okay.
then I would, using scalar factoring, I would use the delta x would then be like, if I, scalar factor was 2, delta x would be 200, delta y would be 300.
Okay, so, but do you know that at this point?
We do not know
Yes,
that.
you don't know that. So, do we have any other order pairs at this point? Can we conclude the changes are proportional at this point? Okay. We'll go back to what I was, now's the time for this. So now I want you to continue adding to your information. I'm trying here.
Question?
Yep. Okay. Question. Alexis.
This might be stupid, but could you, for a change in x and a change in y, could you say 200 and 550, like since the beginning? That's how much they've changed?
200 and 550 would, so what would that imply if we said the delta x was 200 and a corresponding delta y was 550? That would imply
Constant rate.
what's that?
The change since they started.
And it would assume what that we don't know for sure?
Constant rate.
Yeah, that they started at the same time. Again, it goes back to, that would be true if we knew for sure that they started at the same time. Does that make sense?
Yeah, but
That would assume that when painter 1 had painted 0 square feet, also painter 2 had painted 0 square feet. Then you could say those would be corresponding changes. Does that make sense? Okay, keep going. So.
Yeah, zoom in on the right page. So probably finish on what, 4 steps?
oh yeah.
As if they're hanging on That doesn't seem like it's a half
Okay, let's see what you guys came up with. So, Ashley, take your pick, anything you want. So, what's some new information that we have?
X is 500 and Y is 1,000.
She wants that when painter 1 has painted 500 square feet, P2 has painted 1,000. Agree with that? Cool, agrees. Yeah, Brianna.
And then change in x is 300 and change in y is 450.
Okay, so tell me where you're seeing that, or how is that represented here? So
From the 200
okay.
to 500, it changes by 300.
So we'll call that delta. We'll call that delta x1,
Okay.
and the corresponding change in y.
Yeah. Is 550 to 1,000, which is 450.
Is it valid? Did anyone look at this and not see that? It's okay if you didn't, because there's kind of different ways to look at this. Anybody else? Something new?
I looked at it from like the total change,
Sure.
which was 400 and 1,000.
Delta x2.
600, sorry.
So delta x2 is from 100 to 500, so it's 400. And?
Then 400 to 1,000 would be the 600 change.
And it was 600? Okay, so from this, our changes in additional amount painted by P2 proportional, is it proportional to additional amount painted by P1?
Yes.
Morgan, yes or no? Okay, why? What's your reasoning for additional amounts by P2 being proportional to the initial amount, or additional amounts by P1?
And I just looked at where it was changing. The changes are proportional.
And how did you see that they're proportional? What specifically are you looking at?
I mean, I just glanced at it. I'm taking like an educated guess.
Okay.
Of the time.
Okay. Jocelyn?
The way that I thought of it was that like the change in X is like 100%, and then the change in Y is 150%.
Okay.
Like, 100, 150, 300, and then 450.
Okay.
Half of 300 is 150, so it just kind of fit over like that, and it worked as well for the 400 and 600.
So you were kind of you're comparing them as pairs this way.
Yeah.
And what were you seeing as the relationship between those pairs?
Y had 50% more, I guess, than X.
Delta Y, okay. So could we say that delta Y is...
1.5 and 1.5.
Yeah.
Is that kind of what your thinking was?
Yeah. That's kind of what my thinking was, 3 halves.
3 halves, or 1.5 of delta X. Okay. Brianna, was there a different way of thinking about it?
Yeah, I just did change in X over change in Y, and all of them were 2/3.
Would it be okay if I did change in Y over change in X?
Yeah.
And those will all be?
3 halves.
Other ways of thinking, ways that you are thinking about the fact that the changes in X and Y are proportional. Anybody want to offer something else? Okay. This number, 1.5, or 3 halves. How many different ways can we come up with to describe the meaning of that number? There are many. Let's see how many we can get in our class. There are many ways. This number is loaded with meaning. So, what is one way to interpret the meaning of this number 1.5? Anybody?
Scale factor.
Scale factor. So what do you mean? What do you mean by that?
I have to scale x 1.5 times scale y.
Okay.
Or other way around. Scale y 1.5 times scale y.
What's that? So let's complete Joel's thought here. So.
Yeah, you said to scale x 1.5 times to get the value of y.
Okay, changes it.
That change in x. 1.5 times to get the change in the value of y.
Okay, changes in y are sometimes 1.5 times the changes in x. Always 1.5 times changes in x. Changes in y are always 1.5 times changes in x. Okay? What else? Right.
Since that certain point, when painter 1 was at 100 feet and painter 2 is at 400, then every 3 feet that painter 2 paints, painter 1 paints 2 feet.
Okay. So yeah, so for every 2 feet that painter 1 paints, painter 2 paints 3 feet. What else? Yeah, that's good. This number 1.5 though. This number 1.5, what is the meaning of it? Okay, so a constant multiple goes back to changes in y are always 1.5 times changes in x. What else does it mean? Yeah, James. He says painter 2 paints 1.5 times faster than painter 1. Agree with that? Absolutely. Okay. What about the fact that 1.5 is this quotient of delta y and delta x? What is the meaning of quotient? What's the meaning of quotient? What is it? When you divide two numbers, you get a number. What does that number mean? Yeah?
I'm kind of seeing it as like the vertical change or the horizontal change, and I was thinking about like slope, like y equals 1.5x plus, and I was doing more work, plus 250, like that's kind of like the equation you
Okay.
did. I thought it was kind of slope.
So 1.5 is a slope.
Okay.
Yeah? Anybody want to give a stab at our quotient meaning? The fact that 1.5 is the quotient of these changes, what does that mean?
constant ratio that they change.
Okay, it's a constant ratio. Isn't it the size of additional amount painted by P2 relative to the additional amount painted by P1?
So 2 parts to 3 parts.
Yeah. So this side 1.5 is how much painter 2 paints in addition. How much painter 2 paints additionally relative to how much painter 1 paints additionally. So it's a relative size. It's the relative size of painter 2's area painted, additional area painted to painter 1's additional area painted. Relative size. Okay. So Eric talked about slope. What is the formula for slope? Yeah, isn't slope change in y over change in x? So what would the slope be, as Eric said? 1.5. It's also the slope. So what value was the purple bar again? The total length of the purple bar was what? Which, in terms of x and y?
The total area painted by painter 1.
Which was it, x or y?
X.
X. And the green one was? Y. What would I need to do to my, I'm going to erase everything. See ya. What would I need to do to this illustration to have a relevant conversation about slope? How would I have to alter this illustration to have a relevant conversation about slope? What's that? I want to know what I can do to this.
You need to adjust to where their times are together. You need to move the purple bars to that.
I need to make their time start together.
I was going to say you need to rotate them.
Rotate which? Both?
Oh,
Just which one was that? I forget which one was.
X is purple.
Rotate Y and green one.
You want to rotate the green one. Tell me more.
So that the base matches up with the purple one, so that it's going up and down.
So the base matches up with the purple one, so it's going up and
So
down.
on the left side of the green bar,
Okay.
to be vertical on top of the left side of the purple.
But they're not going to be corner to corner
Attach
because.
starting point of the green bar to the end point of the purple.
But they wouldn't be at the end because the times, the beginnings, the initial times is not the same.
We don't know.
Does attaching the ends to this bar make it have to be that the initial times are the same? So what was the suggestion over here? To do, Joel, what did you want to do?
Attaching the starting point of the green bar to the end point of the purple bar.
So attach the starting point of the green bar to the end point of the purple bar.
And have it face up.
Okay.
And then what will happen as we increase the amount that painter 1 paints? Oh, please work. Oh, you're kidding me. That really stinks. That's quite unfortunate.
Did you anticipate that?
No. Definitely not. Let's see, I'll close this. I don't think this is going to help, but I'll try. Please. Oh. What am I going to do? Maybe we can just drag it. Oh, that's great. So I'm just going to drag it by hand.
Well, yeah, I want to play. That's really weird.
Too many windows open on my computer.
Oh.
Sometimes it just does funny stuff. Okay? So what am I showing now by increasing change in x? What am I showing? What point do I need to track to start talking about slope? What point do I need to track to talk about slope? Yeah, actually.
The top of the green bar?
Wherever the top of the green bar is. I'm going to put a red dot on the top of the green bar. And then we're going to track everywhere that dot goes. Think of it like an airplane. It's got its jet on, right? Jet vapor trail. Everywhere that plane goes, it's going to leave a trail. So think of that red dot that way. Okay. So how is the change in x being represented in this picture? So how could you represent change in x the way I have it right here? Matt, where's the change in x?
Horizontal component of your little paper
Okay.
trail.
I think this is what you're saying right here.
That is exactly what I'm saying.
And corresponding change in y. Brianna, where would that be represented in this picture? So maybe the thin part? How does this show us a slope of 1.5? So going back to that meaning of that number, what was the meaning of that number? It meant what?
Change in y over change in x.
It's a
Okay.
relative
For
change.
every.
Okay. And what does that
It's a
mean?
relative change. It relates the change in y to the change in x. In this case, 1.5 represents a unit change in x. For each 1 unit of change in x, there's 1.5 changes in y.
Okay, so how do you see a relationship of 1.5 to these two changes? Delta y is how compared to Matt?
For every 3 units of change that delta y experiences,
Uh-huh.
delta x experiences too.
Okay. What are in this particular delta y and delta x that we're showing? Where does that delta y come from?
Comes
Yeah.
from the extra amount that painter 2 is painted relative to how much painter 1 is painted.
And that is always what multiple?
It's always
1.5.
1.5.
Oops. Okay, this change in y that we see right here is 1.5 times as long as that change in x. So the corresponding change is always 1.5 times the change in x. So if painter 1 paints 100 more, how much will painter 2 paint? 150 shown right there. See that? If painter 1 paints 200 more, painter 1 will paint, or sorry, painter 2 will paint 1.5 times as much as that. Okay, how can it be? So any questions about slope? How slope is the rate of change? The relative size of every change in y. So any change in y that you pick, that will be 1.5 times as great as the corresponding change in x. So that's the relative size of changes in y relative to changes in x. 1.5 times as long. If they are painting, if the changes are proportional and painter 2 is always painting 1.5 times as much as painter, 1.5 times as fast as painter 1, how is it possible that painter 2 could have painted 400 square feet when painter 1 had painted 100 square feet? So how is that possible? So some of you already touched on it, but pretend we haven't.
Yeah.
Don't say the number. Don't say the number. Just say, how is it possible? Just how is it possible?
Painter 2 started with the house that already had been painted, like some of the area painted on.
Okay, so when painter 1 started painting, Painter 2 had already started. Okay, so using the idea of rate of change, forget everything you've learned about linear function. Use the idea of rate of change and what we just talked about with this number 1.5 to figure out how much has Painter 2 had he painted when Painter 1 started. Okay, so just using rate of change. So forget all the equations of linear functions you ever learned. Just from the ideas that we just laid out, figure out how much would Painter 2 have had painted when Painter 1 started. Okay, so share your ideas. So talk it out. Okay, I want you to start. So did anyone focus on starting at this point right here, 100, 400? Did you, Christopher, tell me.
Yeah, I started at the point 100, 400.
Okay.
And since we were given that the change is change in y and over change in x is 1.5.
Okay.
We were saying that, well, for the distance or the from 0 to 100, that length is 100 square feet of paint that is in between them.
Okay, so what's the change in x? I'm sorry, I cut you off.
No, that's okay.
Okay.
That's okay. That's okay. And we were saying that since delta y is equal to 1.5 times as much as the change in
Good.
x, we were saying that, well, since x changed by 100 square feet of paint,
Okay.
the change in y would have had to be 1.5 times as much as that.
That's right.
And so therefore, the result would be that it would be 400 minus the result of 1.5 times delta x.
Okay. Exactly. So starting at 100 and 400, we want a change of x. If we want to know when Painter 1 hasn't painted anything, we want a change of x of negative 100. Agreed? And we said that because we have proportional changes, that the changes in y are always 1.5 times whatever the change in x is. So that means the corresponding change in y would be negative 150. So the new y is just the old y plus what? Plus the change in y. Old y was 400. Change in y 150. So Painter 2 had painted 250 when Painter 1 started. Okay, so reasoning based on constant rate of change. So now what I want is let's turn on the axes here. So really and I want to turn that off now. This. Really, so we're graphing here. We're graphing in Cartesian coordinates, x and y. So starting at that point, 100, 400, I'm going a little fast here, don't want to run you guys over. Now I want to know, given any point x, so just suppose this is just any x, I want a definition to find me the amount that Painter y paints, total amount, knowing that we're going to pick some amount that painter 1 has painted, some total amount, just any amount x. So we start at 100, 400. And with the same reasoning we just used, what will we do first? So I want to know, I'm interested in knowing now the corresponding amount painter 2 has painted, total, to any given x. Any given x. So using the same reasoning as before, how are we going to start?
With 1.5.
We start with 1.5. Is that what we started with? What's that? Delta x. What is delta x from 100 to any value of x? What's the change in x? Frank? X minus 100. Jason? What's the corresponding change in y?
X minus, or y minus 400?
Y minus 400. But we want to do this in terms of x. So y is going to be what we're trying to find in the end, so we can't really use it.
Now we do 1.5.
So what is changes in y are always? They're always 1.5 times our changes in x. And how do we find the new y? The new y is? Let's write that out again. New y equals old y plus delta y. So we're ready to do it. What is the definition of this linear line? Delta y is 1.5 times my change in x plus my old y. Okay, so this is, we could call this, if we want it in function form, we could say that y values as a function of x are always 1.5 times x minus 100 plus 400. That gives you the total amount that painter 2 has painted, given any total amount that painter 1 has painted. And we know all this, so we know exactly where everything comes from there. Okay, so generalizing that, if we have the slope, it's going to be the slope times x minus a plus b, where a, b is any point on the graph, and the rate of change is m. So given a rate of change of m, any point on the graph, we can write a definition for every y value this way. Did I make it? 1 minute to spare. Anybody have a question? I kind of cruised to that last part. Jocelyn?
Why not just do y equals 1.5x plus 250?
Why not just do y equals 1.5x plus 250?
When you leave it like that, it's easier to see what each part represents.
Okay.
Like the 1.5 is the change, where x minus 100 is your value of, what do you call it? Or your delta x, sorry. And then that, I don't know, it's easier to break down and see like what all the parts mean. Whereas if you put it as 1.5x plus 200, you don't really know where the 200 came from. Or 250, sorry. 250.
So where did that come from when you said that?
Because we knew that when, well, we know that the rate's 1.5 for the whole thing, and that it started, we found how much P2 had already had finished when P1 started.
Okay.
So that's your y intercept.
Yeah, if you can reason through it without saying, oh, I learned mx plus b in high school, then it's valid. So we just want to avoid this, y equals mx plus b is like, it's what we, worship for lines. Yeah.
So just what you said, I think it was last class, good answers don't need to be rewritten for every problem.
What's that?
Good answers don't need to be rewritten for every
Okay, so how does that apply here?
It's a general formula given any points.
Okay. Good. Okay. So, again, tonight I'll try to update everything that'll be for Monday. Okay? Have a good weekend.